Right, hey everyone, welcome back in. We're going to be moving on into our next unit, which connects together a few different topics from things that you would have seen over the last few activities, from the average speed stuff into vectors and the difference between displacement and distance and velocity and speed, and then moving into some of the ideas with the graphic motion coming up. So with two-dimensional motion, it starts off, says what are two characteristics that all vectors have. And hopefully with this, what we're understanding or realizing is that all vectors, they have magnitude, so they have a distance that they can travel, as well as they have a specific direction that they're running in. So for instance, I might have traveled 10 kilometers heading north. That would be an example of a vector. Or I might say that I'm going at 50 kilometers an hour southeast, right? Again, a vector quantity because it has a magnitude and a direction. So vector quantities have both of those things, and so in two dimensions we need to be able to communicate this really easily. And for this unit, you're really going to need a ruler and a protractor. And so I do have both of those in my room available for you to borrow if you need one to use. And so all you have to do is ask when you get to this point. But if you have a ruler and a protractor, that'll really help for this section. So they can be used to draw precise vector quantities with proper compass directions. The compass that you see on the side over here has our traditional compass bearings, northeast, south, and west. But we also have these other ones that are in here, like northeast and southwest and northwest. And so those ones are really exactly 45 degrees in the middle of two of the other headings. So for instance, if I were to look at east and north and look between them, I have a bit of a right angle here. So we know that right angle would be 90 degrees. And so if I were to take a look halfway between there, like say between my north and my west right here, this one would be half the 90, so I would expect that to be 45 degrees. So I can talk in terms of northwest, northeast, southeast, southwest if the answer is exactly 45 degrees. But what if it's greater than that 45 degree marker, and what if it's something that's a little bit smaller? How do we start to write those out to show them? So as an example, to start us off, we'll get a ruler and a protractor, and I have some that are available to draw these vectors out. The first two, A and B, really the ruler measurement should do the trick, centimeters and millimeters to take a look, and then I have these compass bearings that are here for you to try. And then after that it says for C to make up a convenient scale. So obviously you're not going to draw a line that's 4.9 kilometers long. That would be very ridiculous to do, but we can easily make up a scale that we can use to show something on a page. So pause the video, get the materials that you need, and just try to draw what those angles would look like. So I have a picture over here on the side kind of showing that compass direction and saying, it's 11 meters at 49 degrees west of north. And so you can see the 49 degree marker that's there, and it's showing it's going west of the north direction. So it's 49 degrees away from north heading west. So take a second, you could use that as an example and try just to see if you can sketch out what those are. And when you're ready, come back and we'll go through them. All right, so for each of these ones, we're going to use our compass direction. And we're going to use this as kind of like just a way to quickly show what these look like. And so with your protractor, if you're not sure how to kind of read everything, it happens every time we go through where maybe we need a little bit of a reminder on how to use some of this stuff. Just keep in mind that if you're reading your protractor, you're always starting at 0. And so in this case, I'm starting at 0, moving on my outside scale. You can see my numbers here start with 0, 10, 20, 30, 40 on my outside part of my numbers. And so I can match up a line and I can draw an angle from that 0 value from there. Likewise, if I flip this thing, then 0 flips over on the other side over here, and now I have to read this from the inside numbers because I'm starting at 0 on this side. So you always start from 0 and always count your way outward. Okay, so I guess that's one of the bigger points to kind of take away from this. The ruler on the bottom, we're just going to pretend that that ruler represents the centimeter values that we need, and so we're going to read those moving forward, just kind of in the numbers that we would need to get. So let's get an idea for our angle, and in this case I see 25 degrees south of east. So I'm going to get a sense of where that south of east is by looking at my compass. So it's going south 25 degrees from the east direction. So if I took a look at something that was pointing straight east, okay, and I'll get maybe a line drawn for something that I can go off of. So we'll sketch out a line to start with, and that line is heading east. Now after that, I know that I'm heading 25 degrees south from that direction. So I'm going to bring this down here a little bit. I'm going to take my protractor that I have set up, and I have to turn this because I need my 0 degree marker to represent 25 degrees. So I'm going to match up my line, and then I'm going to use my protractor to go down 25 degrees from there. So we'll nudge this out of the way for a sec, measure out 25 degrees, and so this tells me where to go for my angle. And so really on your page, you could just put a dot at the end of your line, okay, somewhere like right here, and then what you would do is you take your ruler and use your ruler to then, the angle that you're at, so we can tilt our ruler and we can measure out what this is going to be at. If I can just get the right value, what this is going to be at if I were to measure this out to be 3.7 centimeters that I need right from here. So 3.7 centimeters looks like it's going to come right to about, so here's 3.5, so it looks like it's going to come right to about here, and then I'm going to use that to draw my line that I have. And so my line is going to go from the beginning, going all the way through to that 3.7 marker, and I'm going to stop right there. Now if I were to move everything out of the way so you can kind of see what the final thing were to look like, okay, this final value now, we can get a sense of what this is. And so all I would do after that is I would just fill in what this is. So we knew that this was 25 degrees, and we know what our magnitude is because our magnitude was 3.7 centimeters. So I could take that as a whole and really use that as my final value for everything filled in for that section. So we're going to take that, and there's our answer for A. Okay, 25 degrees, 3.7 centimeters, using our compass direction and our ruler. And then I would just go through for the other ones and use a similar kind of style, use a similar thing. And for B, this one says 41 millimeters, 12 degrees west of north. So it's 41 millimeters is the same thing as, hopefully you've seen 4.1 centimeters, right? There's 10 millimeters in a centimeter. So I can still use my ruler that I have here and use that to figure out all of my information that I need for these ones. So just going to set this one up. I've got my ruler set up again. I have my protractor set up again. I'm going to turn it over this time because now I'm going west of north. So I'm on the upper half of my compass bearing. So if I'm going west of north, where do I want this to start at? Well, now, how I did that dotted line earlier heading east, now really my dotted line is heading north because that's where I'm starting from. So I'll get my line going north, with the idea that this line is really just telling you a reference point where your angle's coming from. And so with my protractor now, I'm going to turn this, and we're going to see how we can kind of match this up onto here. Now, it doesn't make sense for me to have my angle on the bottom like I have it right now, so I'm going to flip it so I can measure my angle coming from here, from the north direction. So I'm going to take my protractor, I'm going to make this just a little bit smaller, bring that over. I'm going to put the center of my protractor right on the edge of the line where I want it to be. And then I'm going to drag this thing out so it says 12 degrees. So maybe I'll bring this in just a little bit so it says 12, and then I'll bring my line back over it. So you'll want to sit your protractor right on the edge of that line, right in the middle, measure out 12 degrees, and then you can see where that 12 degree marker is. So overall I can see my 12 degree marker is just small, it's just right here. But I need to know how long that is. So 4.1 centimeters from there. Okay, so 4.1 centimeters, I'm going to have to turn this thing, a little bit of an angle, not much of one, and just try to match this up so I can get a fair reading as to where that is. Okay, so 4.1. I want this whole thing to be 4.1 long, which really means that it looks like it's going right to the very end of that ruler to make it 4.1. So again, I'm going to put a little mark where that is, and then that will tell me where I can draw my line from my protractor point in the middle all the way to the end of the distance that I need. Oops, wrong one. So I'm going to go from here all the way along that line right up to where the tip of that is, staying at that 25 degree marker. Let's get a couple things out of the way just so we can take a look and see kind of what we have left over, and then we can see that my final part here, really I've got 12 degrees kind of tucked in this little spot right here. So that'll let me kind of see what this will do in terms of measuring it out and getting my 12 degrees west of north. Now in C, the last part, what I have now is this scale that I have to make. So I have 4.9 kilometers. So what I'm going to say for a scale, and maybe what makes sense the most here, is to say something like let a kilometer equal a centimeter. Okay, 1 kilometer can be a centimeter. And so in this case, 4.9 kilometers just works out to be 4.9 centimeters. It's probably the best way that I can go with my protractor, my ruler, to be able to come up with a scale that will work with what I have. So here I have 18 degrees south of west. So again, I'm going south from my western direction. So I'm going to start with my dotted line heading in the west direction. Okay, so it's heading west. And then I know that I'm going to go 18 degrees south of that west direction. So move this back up here. Let's get that out of the way for now. Now I'm heading south of this direction. So where should I turn this? I should turn this upside down because I need to read south of the west direction. Now if I put this on its end right here, notice my arrow is pointing to the west for the dotted line that I put in. And so I need this blue line to, I guess, A, work out to be the 18 degrees that we need from the question. So turn this to 18 degrees, get that number. And then I need to then match out the length to make sure that it works out to be 4.9 centimeters, which in this case is really going to work out to be 4.9 kilometers. So match this up roughly to where that's going to be. Turn this over so the line matches up to be the same. And then match up the end to be 4.9 centimeters long. So that then tells me where I can draw my line. So my line's going to go 4.9 centimeters from here, right, all the way over to the end, 4.9 centimeters, and it's 18 degrees tucked in there. So after I'm done with those, I can move those out of the way. And what I have left over now is my answer of 18 degrees tucked in there. And then I know that this line is 4.9 kilometers long because a kilometer is a centimeter. So 4.9 kilometers. And while I'm at it, I guess I should really add this one in here too. Okay, saying what that number was to start with. So it has a magnitude and it has a direction. Right? Notice how they're written out up on the top in the ABC part of it. It has a displacement because there's an arrow over it, and that means that it's a vector. Vectors have magnitudes and directions. So in this case, the number is coming first, and then after that it's telling you where it's going in those brackets, 18 degrees south of west. Alright, so we can use these to actually draw any of our problems to scale. So we're going to practice this kind of moving on in the next activity. And so yeah, just from here we'll click on to the next video and continue going through drawing vectors in 2D.